Hello everyone, I am Santosh. My subject is chemistry. Welcome to online platform of Narayana Educational Institutions. The purpose of my presence here is discussing memory-based question paper of JEE Main 2024, January shift, and all the questions we have collected from the memory of the students. And these questions were collected from the second session of 30th January. And the disclaimer is there may be some difference in the actual question. There may be some difference in the options of the question, but our intention is we just wanted to expose the questions to the students, and particularly we have to focus what kind of questions they are asking, to what level they are going, and also after observing the questions, my analysis on the paper is they didn't go beyond NCERT textbook, and out of 25 questions, 10 questions were from inorganic chemistry, 9 questions from organic chemistry, and 6 questions from physical chemistry. So without making any delay, let us get into the first question. So here is the first question. Here the question says, why potassium permanganate shows color? And particularly he is asking the reason for the color of potassium permanganate. So in this potassium permanganate, if you see KMnO4, this is potassium permanganate, and it consists of K plus and MnO4 minus ions. In this oxidation state of manganese, if you see, that is +7, and that means there are no electrons in manganese. Manganese oxidation state is +7, and the color is due to DD transitions. DD transitions, that means the electrons are transferring from ligand to metal. That process is also known as LMCT, ligand to metal charge transfer phenomena. So the color of potassium permanganate, that is dark purple, that is somewhat black in color, and its color is due to DD transitions. So that is ligand to metal charge transfer phenomena. So the correct answer to the question is 3. So here is the second question. This question says C is added to a solution of A and B. So we have a solution of A and B. You are adding another component to this, that is C. And the question is about mole fraction of C. Mole fraction of C. So mole fraction of C can be written as number of moles of C by total number of moles of the components present in the solution. So that is number of moles of C by total number of moles. So that is NC by Na plus Nb plus Nc. So the answer to the question will be first option. The simple question, that is he was asking mole fraction. And the next question is IUPAC name of the compound. IUPAC name of the compound, if you see the question given is CH3 CH3 C triple bond CH. So according to the rules of IUPAC, of course this is the longest chain. There is a functional group called a triple bond, and also there is a substituent. And the basic rule here, generally we say secondary suffix gets more priority when compared to primary suffix. Primary suffix gets more priority when compared to secondary prefix. This is the order of priority we have to give. But here there is no secondary suffix. There is primary suffix, that is "-ine", that is for a triple bond, and also there is a secondary prefix, that is a substituent, that is methyl. So according to this order, primary suffix gets more priority when compared to secondary prefix. The numbering should be done from right side. Therefore, it is 1, 2, 3, and 4. So the name of the substituent is methyl, and it is located at third position, and it is 3-methyl but 1-ine. 3-methyl but 1-ine, or the correct answer to the question will be the second option. So this is from organic chemistry. And the next one, which of the following solution will have the lowest freeze point?
the lowest freezing point. So here, if you see depression in freezing point, delta TF is equals to Kf into M into I. So that is a Vanta factor. And the question is about lowest freezing point. So due to the addition of non-volatile solute, freezing point of the solution, resulting solution, freezing point of the solvent will decrease. That means the resulting solution freezing point will be less. So in this situation, solvent is water, obviously Kf is the same in all the cases. For dilute solutions, we can take molality is almost equal to molarity. So if you substitute the data of various components here, that is the first option, delta TF is equal to Kf into 180 grams of glucose, 180 grams of glucose, weight of glucose by gram molecular weight of glucose, and the volume of solution is 1 liter, and Van 't Hoff factor of glucose is 1. Because it is a normal solute, it is neither dissociating nor associating, its Van 't Hoff factor is 1. And of course, delta TF that is equal to Kf we are getting. That is Kf. Let it be. The second option, if you see, the second option, 180 grams of benzoic acid. 180 grams of benzoic acid, delta TF is equal to Kf into 180 grams benzoic acid. So here that is C6H5COOH, and its molecular mass is 78 plus 44, that is 122. 122, and volume of the solution is 1, and Van 't Hoff factor is not given, but it is actually dissociating solute. So let us take it as 180 by 122, approximately it is coming to be around 1.5. Therefore, I will write it as Kf into 1.5 into I. Let it be I. We'll compare the values. And the third option says 180 grams of acetic acid. Delta TF is equal to Kf into given weight is 180, molecular mass of acetic acid is 60, volume of the solution is 1, Van 't Hoff factor is not given. Actually, this is also dissociating solute, but Van 't Hoff factor is not given. So this will be something like Kf into 3 into I. So here this is delta TF of third option. And the fourth option says 180 grams of sucrose. 180 grams of sucrose. Delta TF is equal to Kf into weight by gram molecular weight into 1 by 1 into I. But here also sucrose Van 't Hoff factor is 1. So it will be something like Kf into 180 by 342. So the depression in freezing point we are finding. Based on that, we can compare the freezing points of the four solutions. So in case of delta T, first option delta TF is equal to Kf. It is 1.5 into I into Kf. It is 1.5 into 3 into I. But here this is Van 't Hoff factor of, let me write it as benzoic acid. This is the Van 't Hoff factor of acetic acid. And here this is definitely less than Kf. So we can eliminate these two options because the depression in freezing point is less. In 2 and 3, if you do the smart work, of course, benzoic acid is more acidic when compared to acetic acid. Its degree of dissociation is more. So let us take the maximum possibility, I value, even if you take, even if Van 't Hoff factor of benzoic acid is taken as maximum, that is 2, you will be getting, this is 1.5 into 2, that is 3 into Kf. But in case of acetic acid, yes, it is definitely less acidic when compared to benzoic acid, and we can say degree of dissociation is less, Van 't Hoff factor is also less, but it is definitely greater than 1. Any value of greater than 1 you substitute, you will be getting delta TF will be more for acetic acid solution. Depression in freezing point is more. Depression in freezing point is more. So obviously the freezing point of the solution will be least. So based on that, we can go for the choice of option 3. So here this is from colligative properties. So depression in freezing point. And the next one, arrange the following according to their decreasing oxidizing power. Decreasing oxidizing power. So here oxidizing power, it totally depends on oxidizing power of any substance. It depends on SRP values, standard reduction potential values. And here the given species, one is BrO4 minus, one is IO4 minus, another one is ClO4 minus. Purely this question is based on data, and SRP values order is like this: BrO4 minus is greater than, IO4 minus is greater than, ClO4 minus. So based on that choice, we have to go for the answer to the question is the second option. The question is arrange the following according to their decreasing oxidizing power. So oxidizing power depends on standard reduction potentials. And the next question is salicylaldehyde. So here salicylaldehyde that is orthohydroxybenzaldehyde. Orthohydroxybenzaldehyde, that is salicylaldehyde. And the question is salicylaldehyde forms from phenol, and he is asking us to prepare salicylaldehyde from phenol. So phenol undergoes electrophilic substitution reactions, but here we need to install formyl group. Installation of a formyl group, that is definitely possible in Reamer-Tiemann reaction. Reamer-Tiemann reaction. So the suitable reagent for this is CHCl3 and NaOH. If you use carbon dioxide, you will be getting orthohydroxy benzoic acid, that is salicylic acid. And here the best option, that is Reamer-Tiemann reaction. Even if you use CCl4, you will be getting carboxylic acid only. So it is basically an electrophilic substitution reaction, installation of formyl group, electrophilic substitution. This reaction is Reamer-Tiemann reaction. So the suitable reagent for this transformation is chloroform and NaOH. If you can recollect, electrophile in this is dichlorocarbene. Dichlorocarbene. Yes. And the next question, complete the following reactions and find major products A and B. Major products A and B. The given substrate of this reaction is 2-methylhexene, cyclohexene, sorry, 2-methyl cyclohexene. And two pathways he provided. And the first one is, if you see the reagent properly, that is hydroboration followed by oxidation. Hydroboration, HBO, hydroboration followed by oxidation. Hydroboration is the first step and oxidation is the second step. And the next one, next pathway is just hydration, as acid catalyzed hydration. So this is from alkenes, we can say. Alkenes undergo electrophilic addition reactions. And here we are going to install H and OH in place of pi bond. This installation can be done in three different ways. The first one is acid catalyzed hydration, second one is oxymercuration and demercuration, and third one is hydroboration followed by oxidation. But in this he gave two pathways. One is hydroboration followed by oxidation, another one is acid catalyzed hydration. And here in case of HBO reaction, net reaction is addition of water. The result is no rearrangements, nothing. Addition of water according to Markovnikov's rule. According to Markovnikov's rule. Even after writing the mechanism, you have to take the same conclusion. Installation of water according to Markovnikov's rule. As a result, here you will be getting the product, that is, so here this is CH3 and OH has to be installed here and hydrogen has to be installed here. Net reaction is addition of water according to Markovnikov's rule. But in the second path, acid catalyzed hydration. So here it's better to go with the mechanism. The first step of the mechanism is addition of electrophile. Electrophile is added to cyclohexene system, and electrophile is added in such a way that carbocation intermediate is produced. This is one possibility. And another possibility is this one. Hit and trial I am taking. This is a secondary carbocation and this is a tertiary carbocation, and obviously the reaction proceeds through more stable carbocation intermediate, so that transition state, so here that is energy of that transition state will be less, reaction will be faster. So this is more stable intermediate. In the next step, electrophile addition is completed. Next you have to add nucleophile, here that is water. Addition of electrophile, that is the first step, in fact rate determining step, and here this is addition of nucleophile. So here water is added, and of course in the last step you have to go for loss of proton, loss of proton. So here whatever the H plus consumed in the first step, that is coming out in the last step, therefore we have to say it is acid catalyzed hydration. And here he is asking A and B respectively. So here this is installation of, so here this is your answer A, and this is major product, that is B. So obviously the answer to the question will be second option. So this is electrophilic addition. Net reaction is addition of water. So here let us move on to the next question. Again the question is on IUPAC naming, and let me take the structure here. So that is CH3. So this is CH, CH2, CH2, C triple bond N, and this is NH2. So you have two different functional groups. One is cyanide functional group. IUPAC suffix is nitrile. Amine functional group. According to IUPAC sequence rule, priority rule, cyanide functional group gets more priority. Therefore, its name will be secondary suffix, and NH2 will be treated as a substituent in this example, in this compound, in this structure. NH2 will receive substituent treatment, and its name is secondary prefix, secondary prefix. So while numbering, suffix gets more priority, therefore numbering should be started from right side, 1, 2, 3, 4 and 5. The prefix name of NH2 is amino. Suffix name of cyanide functional group is nitrile. So obviously the name of this compound is 4-amino. 4-amino. Root word, 5 carbons are present, therefore pent. Primary suffix ane, and here at first position, at first position there is a cyanide functional group, its suffix is nitrile, so that is pentane. So here that is pentane nitrile, pentane nitrile, pentane nitrile. So 4-amino pentane nitrile. So here that is first option. So this is the second question on IUPAC naming, and the next one, in the given reaction, in the given reactions A and B respectively, in the given reactions A and B respectively. So this is a qualitative analysis, salt analysis, chloride ion test, chromyl chloride test, we can say chromyl chloride test. So here this is CrO2Cl2, CrO2Cl2 on reaction with NaOH, that gives Na2CrO4, sodium chromate, with the removal of NaCl and water. Of course, this is yellow colored solution, and you are adding hydrogen peroxide oxidizing agent and also sulfuric acid H2SO4. If you can recollect, it is going to give a blue colored compound that is chromium peroxide, CrO5, CrO5. So here chromium surrounded by 5 oxygens, and of course there is a peroxy linkage here. Here also there is a peroxy linkage, and oxidation state is +6, but it's not about the oxidation state, but here he's asking one is A and another one is B. So obviously the answer is the first option. A is sodium chromate and B is chromium peroxide. And the next one, which of the following has square pyramidal shape? Square pyramidal shape. So here square pyramidal shape is possible. So here this is a square, this is a pyramid, and also there must be one lone pair. So here this is a bonded atom. So here there are 5 bonded atoms, 4 are occupying the corners of the square, 1 is above the square, 1 lone pair that is below the square. So that is a square pyramidal, square pyramidal. So if you take a PCl5, in case of PCl5, so here this is sp3 dehybridization and it is a trigonal bipyramidal. Of course in gaseous phase, trigonal bipyramidal. So here this is PCl5. So phosphorus has no lone pair. 5 bonded atoms are present, but phosphorus has no lone pair. In the valence shell of phosphorus, 5 electrons are present and all the 5 electrons are utilized in bonding. But the requirement is 5 bond pairs and 1 lone pair. And the next one is BRF5. BRF5. Bromine is the central atom. Its valence electrons is 7. According to the formula, 5 fluorines are surrounding. 5 electrons of bromine are utilized, which means there is 1 lone pair. So 5 sigma bonds and 1 lone pair. So here totally the hybridization is sp3d2. So this is the required geometry, square pyramidal. So the answer is BRF5. Of course PF5, that is also trigonal bipyramidal. NiCN4 -2, that is square planar. And the next question, find out the correct order of stability of given carbocations. He gave 4 different carbocations. The first one is tertiary butyl carbocation, tertiary butyl carbocation, and the second one isopropyl carbocation. The next one is ethyl carbocation, and the last one is methyl carbocation. The carbocation, it has a positive charge. If there is any electron donating group, that will stabilize the carbocation. EDG, electron donating groups, will increase the stability of carbocations. Of course, here we have 3 methyl groups. Each methyl group contains 3 hydrogens. Totally there are 9 alpha hydrogens. Here there are only 2 methyl groups. Each methyl group contains 3, so that is 6 alpha hydrogens. And only 1 methyl group, 3 alpha hydrogens. And here no alpha hydrogens. Of course, hyperconjugation increases the stability of carbocations. So methyl carbocation is more stable than isopropyl carbocation, than ethyl, and least stable is methyl carbocation. So the same order, 1 greater than, 2 greater than, 3 greater than 4. So this is again general organic chemistry, stability of carbocations. And the next one, statement 1, halogen attached to a bulky group. And here the statement 1 talks about SN2 reaction. If you can recollect, SN2 reaction proceeds through pentavalent transition state. Pentavalent transition state. So here let us say this is, so here one hydrogen, and here this is one group, let me write R, and here let me take one atom, that is deuterium, anything it may be. Pentavalent transition state. So here this is living group and this is attacking group. When you are comparing the rate, we have to study the stability of pentavalent transition state. Halogen attached to bulky group. If this group is bulky, when the group is bulky, there will be some steric crowding. When there is a steric crowding, potential energy of that transition state will be high. When potential energy of a transition state is high, for example, this is your reactant and this is your product and this is your transition state. It is a single step reaction, concerted reaction. All the changes are taking place in one step. See, this is activation energy, and if transition state has more steric hindrance, its potential energy will be more. When potential energy is more, activation energy will be more. When activation energy is more, reaction will become slow. But it says halogen attached to bulky group undergo SN2 reaction, that is difficult. So statement 1 is a wrong statement. Secondary alkyl halide react with excess of ethyl alcohol. Secondary alkyl halide, it is allowed to react with excess of ethyl alcohol. Excess of ethyl alcohol. So here this is a solvolysis reaction. Secondary alkyl halides can undergo SN1 reaction, and it is a solvolysis reaction. You are using solvent, that is ethyl alcohol, and it is acting as nucleophile also. So it definitely, under given conditions, it will definitely undergo SN1 reaction. Therefore, statement 2 will be the correct one. Statement 1 says halogen attached to bulky group undergo SN2 reaction. That is a wrong statement. So statement 1 is false, statement 2 is true. So that is there in the fourth option. So the answer to the question is 4. So let us move on to the next one. Consider the following statements. Again, statement question. Statement 1 says, since electronegativity of fluorine electronegativity is greater than hydrogen. Yes, that is correct statement. Fluorine is greater than hydrogen. So dipole moment of NF3 is greater than NH3. But the first part of the statement is correct. But he is comparing the dipole moment values of NH3 and NF3. NH3 and NF3. And here both are pyramidal molecules. And if you see, in order to compare the dipole moment, we have to see the bond moment. Nitrogen and fluorine is more electronegative, therefore the bond moment is towards fluorine, towards fluorine, towards fluorine. But here this is away from nitrogen. That means they are in opposing direction. When the bond moments are in opposing direction, there will be some cancellation. Even though electronegativity of fluorine is more, but here the bond moments are in opposing direction. But in case of ammonia, nitrogen is more electronegative, the bond moment is towards nitrogen, and it is towards lone pair. But in case of ammonia, the bond moments are added, but in case of NF3, there is a partial cancellation. Therefore, dipole moment of ammonia is greater than dipole moment of NF3. NF3 dipole moment is less. But the second part of the statement says dipole moment of NF3 is greater than NH3. Therefore, this is a wrong statement. Lone pair dipole in ammonia is not in the direction of resultant bond dipole, while in case of NF3, the lone pair dipole is in the direction of resultant bond dipole. Lone pair dipole in ammonia is not in the direction of resultant bond dipole. Resultant bond dipole. And NF3, in case of NF3, the lone pair of dipole is in the direction of resultant bond dipole. So in this, the first statement is definitely wrong statement. So this is not the answer. This is not the answer. And here, If you compare the statement lone pair of dipole in ammonia is not in the direction, lone pair of dipole in ammonia, so this is lone pair and this is hydrogen, this is hydrogen, this is hydrogen, this is in this direction, is not in the direction he is saying, but they are in the same direction, therefore that is also false statement, therefore both the statements are false, hence the answer is 3. Next one, the magnetic moment due to the motion of electron in nth orbit of Bohr atom is proportional to n power x. N power x is, of course, he is talking about magnetic moment. In fact, magnetic moment is directly proportional to angular momentum. Angular momentum is directly proportional to n. So obviously here n power x, so it must be 1. So the answer will be 1. And the next one, sequence of reactions were given. The first one, that is benzene. So here benzene, 2 different reagents were given in the first step. The first one causes nitration. The first one causes, that is nitration mixture. He used incoming electrophile is NO2, so the product is nitrobenzene. In the same step, by using second reagent, he reduced nitro group SnHCl he used. So because of that, that will be converted to aniline. So here this is the first reaction in the sequence. So this is A. So this is nitration and this is reduction. So the product of the first reaction is, that is aniline. Aniline, it is subjected to diazotization. Diazotization. So first, that is going to give benzene diazonium salt, N2 plus Cl minus. Diazotization reaction, and that is benzene diazonium chloride, but he gave one more reaction, that is a diazocoupling reaction. Diazocoupling reaction. So here this is your diazonium salt, it will act as electrophile, and the second one, phenol, is undergoing electrophilic substitution. So this is acting as electrophile and this undergoes electrophilic substitution. So particularly that substitution takes place at a para position and the product is azodi. So here N double bond N, and that is para position, at a para position of phenol. So the product will be, A is aniline, B is azo compound, but here there must be only one OH group. So here this is only hydrogen, that is only hydrogen. So here this is ruled out, aniline is given, this is also ruled out, at other position he gave, and obviously this is also ruled out because additional OH group. So you have to go for the first option. Next question, which of the following is a purification method which is based on solubility of a compound? Practical organic chemistry, purification of organic compounds. And in this, the first option is distillation. The first option is distillation, and this distillation technique depends on boiling points. If the components present in the mixture have different boiling points, generally in that situation we choose distillation process. And the second option says sublimation. Second option is sublimation. So generally this sublimation technique we use when the impurities, so here sublimable impurities, sublimable impurities, that is the condition. And the third option is crystallization. Third option is crystallization. And this is definitely based on solubility. Based on solubility. For example, we have two components in the mixture, one is A and another one is B. For example, if it is one is more soluble and another one is less soluble, so if solubilities are different, when you control the temperature, one of the components will be remained as precipitate, and remaining that is subjected to crystallization, which is present in the solution. So crystallization technique generally we choose when solubilities of the components are different. And the next one, that is column chromatography. So this technique we use when adsorption tendencies are different. But here, which of the following is a purification method which is based on solubility? So if solubilities are different, we use crystallization. So the answer will be 3. And the next question, hydrogen telluride is more acidic than H2S. So sulfur and tellurium, they belong to 16th group. So that is oxygen, sulfur, selenium, tellurium and polonium. He gave hydrides of 2 elements, one is sulfur, another one is tellurium. So in this we have SH bonds. In this we have SH bonds, sulfur and hydrogen. And here we have tellurium and hydrogen bonds. So this is using orbitals of second shell, this is using orbitals of third shell, and this is using orbitals of a fifth shell. So here the bond strength is relatively more, and here the bond strength is relatively less, because size of overlapping orbitals. Sulfur hydrogen bond is stronger when compared to tellurium hydrogen. So weak bond will undergo dissociation fastly. So H2Te is more acidic than H2S when you are comparing the acidic strength of hydrides. We have to see the bond strength. So H2Te that has a weak bond, so it is more acidic. Therefore, statement 1 is correct. Statement 2 says H2Te has more bond dissociation energy. No, it has less bond dissociation energy. Therefore, this is the wrong statement. Therefore, statement 1 is correct. Statement 2 is incorrect. So, the answer is the fourth option. And the next one. What is the structure of Mn2CO taken 10 times? So, this is from complex compounds. So, there are 2 manganese, and totally there are 10 carbon monoxides. 10 carbon monoxides will be distributed equally. So here 5 carbon monoxides to left side manganese and 5 carbon monoxides to right side manganese. So here the structure will be, so here this is carbon monoxide, this is carbon monoxide, this is carbon monoxide, this is carbon monoxide. So here each manganese is having 5 carbon monoxides. Even here also the same situation, carbon monoxide, carbon monoxide, carbon monoxide, and there is a bond between 2 metals. In fact, each manganese is surrounded by 6 bonds. They are occupying the corners of octahedron. But if you see the statements carefully, 2 square pyramidal units joined by bridging carbon monoxide. In fact, there is no bridging carbon monoxide. This is a wrong statement. 2 square pyramidal units joined by manganese-manganese bond. Yes, if you take only this unit by neglecting manganese bond, yes, it is like a square pyramid. So here this is manganese, 4 carbon monoxides at the corners of the square, and one is like a pyramid, and this is joined. So 2 square pyramidal units joined by manganese-manganese bond, therefore this is the correct. So the answer is second option. Again, the question is from organic chemistry. What are the products of the reaction of metachlorobenzaldehyde? Metachlorobenzaldehyde. This is benzaldehyde, metachlorobenzaldehyde. This is treated with 50% KOH, that is concentrated KOH, and obviously this is an example of Cannizzaro reaction. So Cannizzaro reaction, there is no alpha hydrogen and it undergoes Cannizzaro reaction. This is a disproportionation reaction. One unit will undergo oxidation, another unit will undergo reduction. So here, this is a disproportionation reaction. This becomes carboxylic acid and another unit is becoming alcohol, but acidification is not given, but in KOH. So obviously that is in the form of COO minus. So one product is metachlorobenzoate and another one is benzyl alcohol with a substituent chlorine at a meta position. So that will be the first option, because here he gave one substitution. This cannot be substituted, this chlorine cannot be substituted. Aromatic nucleophilic substitution reactions are possible only if there is electron withdrawing group at suitable position. So the answer will be the first option. And let us move on to the next question. There is a regular increase in chemical reactivity from group 1 to group 18. Group 1 to like this 18. So for example, here if you take, this is the 17th group, that is halogen family. Halogen family, they are non-metals, they are most reactive. And here we have metals left to right. So here electronegativity increases, also I can say electropositivity decreases. So these are most electropositive metals, more reactive. But when you move from first group to second group and second group to third group, electropositivity decreases, reactivity will also decrease. After that, electropositive element is becoming electronegative element and electronegativity increases, reactivity will also increase. So the correct statement must be like, initially reactivity decreases then increases, but he is saying there is a regular increase in chemical reactivity from group 1 to group 18, therefore that is a wrong statement. For example, if you take in his block, first group to second group, reactivity decreases. Oxides of group 1 elements are basic. Yes, metal oxides are basic, and oxides of 17th group, these are non-metal oxides, they are acidic. So statement 1 is wrong, statement 2 is correct. So the statement 1 is false and statement 2 is correct. So that is in third option. And question number 21. How many spectral lines are obtained when an electron in He plus ion jumps from n is equal to 5 to n is equal to 1? So here this is a helium ion, n is equal to 5, n is equal to 1, and this is the nucleus. But the question here, exactly there are many helium ions or one helium ion, that is not clear. Therefore, I'll give you both the possible options. In the first situation, I'm considering many helium ions are present. Let us consider many helium ions. In this situation, you can solve the question by using the generalized formula, that is total number of spectral lines. Total number of spectral lines possible when many ions are present in that de-excitation process. So that is equal to x into x plus 1 by 2, where x is higher energy level, energy of principal quantum number of higher energy level minus principal quantum number of lower energy level. So in this transition, higher energy level principal quantum number is 5, lower energy level principal quantum number is 1. Therefore, x is equal to 4. So here that is 4 into 5 by 2. So that is, you will be getting 10 spectral lines. In what situation? If you take many He plus ions. If there is only one He plus ion, one He plus ion cannot produce 10 spectral lines. That is impossible. So in that situation, if there is only one He plus ion, but practically this is not possible, theoretically, because taking one He plus ion is impossible. while recording the spectrum. In that situation, let us take, in order to get the maximum number of spectral lines, so here 5, 2, 4, 4, 2, 3, 3, 2, 2, 2, 2, 1. These are the possibilities. Maximum number of spectral lines. Maximum number of spectral lines. So 5 to 4, one spectral line. 4 to 2, 4 to 3, one spectral line. 3 to 2, one spectral line. That is the third spectral line. And this is the fourth spectral line. In that situation, maximum number of spectral lines is 4. That means if there is only one He plus ion, and if it is about maximum number of spectral lines, that is 4. And if that electron directly jumps from 5th orbit to 1st orbit, and there is only one spectral line, so that is minimum number of spectral lines. Already told you, all the questions were extracted from the memory of the student. There might be some difference in the exact question, but here there is some ambiguity. How many spectral lines? But this here it's not saying whether it is maximum or minimum, whether there are many He plus ions or only one He plus ion, but all possible answers. If there are many He plus ions and the total number of spectral lines, so that is 10 is the answer. If there is only one He plus ion and maximum number of spectral lines will be 4, minimum spectral lines will be 1. And the next one, what is the value of enthalpy change of delta H? So here we have to derive this equation. So that equation is, so here, sorry, this equation we have to derive. But in this, if you see, there are 3 carbons, carbon is present here. So let me multiply the first equation. So here this equation by 3, because I need 3 moles of carbon. 3 moles of carbon, 3 into 1 by 2 moles of oxygen, and 3 moles of carbon monoxide, and delta H1, let me write 3 into minus 110 kilojoule per mole. So I'm multiplying the equation by 3 because the required equation needs 3 moles of carbon. And of course here 2 moles of iron, here also 2 moles of iron, but iron should be product side. Let me reverse the second reaction. Let me reverse the second reaction, that is Fe2O3, that gives 2 moles of iron and 3 by 2 moles of oxygen. And since the reaction is reversed, it will be exothermic reaction that becomes endothermic. So that becomes what we call delta H2 is 824 kilojoule per mole. So according to the required equation, you need to add both the equations. When you add both the equations, so 3 by 2 O2, 3 by 2 O2 gets cancelled. So that becomes 3 moles of carbon reacts with Fe2O3, that gives 3 moles of carbon monoxide and 2 moles of iron. When the reactions are added, same thing, delta H of the process is delta H1 plus delta H2. So that is the answer. So let us move on to the next question. The number of elements which give flame test. The number of elements which give flame test in the given sequence. So totally 6 metals were given. So cobalt and nickel do not give any color, or at least colorless or silvery white. So generally that is not taken into consideration. So excluding cobalt and nickel, so strontium gives, copper gives, calcium, and even iron. So the answer will be 4. So let us move on to the next question and consider the given reaction, and the equation is N2O4 is undergoing decomposition to NO2. A dimer of nitrogen dioxide, that is N2O4, is undergoing dissociation, and that is giving 2 moles of NO2. And the question clearly says the initial concentration of N2O4, initial concentration of N2O4, that is 3m. And the reaction is allowed to undergo, the reaction is performed for 30 seconds, that is 0.5 minutes. After completion of 0.5 minutes, the concentration of N2O4 was found to be 2.75 m. 2.75 m. And the question is, after 30 seconds, find out the rate of formation of NO2. So this is the equation given, and the rate of N2O4, rate of N2O4. So here the coefficient is 1. That is equal to, so here that is 1 by 2 times of rate of NO2, rate of formation we can say. N2O4 is getting consumed, NO2 is formed. But the question is about rate of formation. Therefore, rate of formation of NO2 is 2 times of rate of N2O4. Even from the stoichiometry also you can see, if 1 mole of N2O4 disappears, in the same time you will be getting 2 moles of NO2. And here the change in concentration. So here rate of N2O4, let me find rate of N2O4, that is a change in concentration by change in time period. Change in concentration is 3 minus 2.75 by, but here the required units are minutes, minute inverse, therefore that is 30 seconds, which is equal to 0.5 minutes. So here that is 0.25 by 0.5, which is coming to be 1 by 2. But the question is not about rate of N2O4, the question is about rate of NO2, which is actually 2 times. Therefore, rate of NO2 is 2 times of rate of N2O4, which is equal to 1. The units are also mole, liter inverse, and minute inverse. So the answer will be 1. And question number 25. How many of the following shows disproportionation reaction? Disproportionation means it has to undergo oxidation and reduction. It has to have the ability of undergoing oxidation and reduction. In this, the first compound in the sequence, hydrogen peroxide, in this oxidation state of oxygen is -1. Minimum oxidation state of oxygen is -2. Maximum oxidation state of oxygen is +2. But here this is intermediate to the minimum and maximum. Therefore, H2O2 has ability to undergo disproportionation. And the next one is Ag. Since it is a metal, it cannot exhibit negative oxidation state. Therefore, it cannot. And copper, the given species is copper +1. Maximum oxidation state of copper, that is +2 we can take generally, and copper 0 is also possible. So the given oxidation state is intermediate to copper +2 maximum and minimum, therefore it has ability to undergo disproportionation. And K plus, so here its maximum oxidation state is +1, further oxidation is not possible, therefore it can undergo only reduction, so that has to be ruled out. And the next one is element fluorine is given. The minimum oxidation state of fluorine is -1 and the maximum oxidation state is 0. Already it is 0. Oxidation of fluorine is not possible. Therefore, we have to rule out even fluorine from the list. And the next option is chlorine. Minimum oxidation state of chlorine is -1. Maximum is +7. The given oxidation state is 0, which is intermediate to minimum and maximum. Therefore, chlorine has the ability to undergo disproportionation. And the last option in the sequence is ClO3 -1. Here the oxidation state of chlorine is +5 in the given species. Minimum is -1. Maximum is +7. So the given oxidation state is intermediate to minimum and maximum. Therefore, it can undergo. So totally hydrogen peroxide, copper +1, elemental chlorine, and ClO3. These 4 species can undergo disproportionation. Therefore, answer to the question will be 4. So these are the 25 questions extracted from the memory of the students. As I said before, there may be some change in the actual question, but our intention is we just wanted to expose what is the depth of the question, to what extent they are asking, and this is the discussion. Thank you very much.